Hey, how's everyone doing today? Welcome to another video in my Homelab series. In this video, we're going to be actually doing some more GitLab stuff. Yay! We're going to actually be doing a GitLab pipeline deployment and updating in configuration file and then deploying it to a server. This is very useful for, if you're using GitLab as a CI/CD utility to be able to push out like an artifact or like a war or anything to a server so that it can actually deploy out an application. But in this case, we're just going to deploy out a configuration just to kind of show you, hey, how you can do it and what you can kind of utilize it for. So this video is also sponsored by me, myself, and I. So if you enjoy the content, want to sponsor me, send me an email in the description below. Also, if you want to send me some free swag with some free hardware, that also works too. So all right, without further ado, let's get started, guys. All right, so the first thing in our last video, we created a container in GitLab. So we're going to utilize this container, but the first thing that we'll need to do is actually go onto the GitLab runner, well, SSH to the box, and edit the Docker configuration. The reason why we have to do this is because we're using HTTP instead of HTTPS for our container repository. So by default, Docker will essentially just bark to the fact of it's not secure, so it won't do it. So we gotta enable it to actually be able to hit it insecurely. So in here, we'll create the this file, and we will also set it up so that it works with this insecure registry. There we go. So it essentially just says, hey, this registry, which is our gitlab.dragon.local on port 5000, it's okay to use HTTP instead of HTTPS. So we'll update that. We'll restart Docker. If you don't restart Docker, it won't take this into effect, and then you'll run into more issues. So make sure you actually restart it. Confirm that the GitLab runner restarted. Up is 2 seconds ago. Okay. So now what we should be able to do, so we'll create a new project. We'll name it DNS because what we're actually going to do, if you remember back all the way in one of our first videos, we created a DNS server, right? So we're going to actually use the zone that we created back then and put it into GitLab, and then have GitLab, whenever we make a change, upload it to the server and then restart or reload the zone file. So we have this new thing here. So we'll add the zone file. So add dragon.local.zone was the file. So let's go here. DNS cat var name the data dragon.local.zone. So this is the file we're gonna use. So we'll create like a test registry in here, just to show that what we did here actually uploads to the server and is used, and the new configuration file works. 1.133. It doesn't really matter. We can overlap this because it just means both folders low. The other neat thing is you want to make sure that the serial number is updated, otherwise it won't actually load it. All right. Now we need create our CI pipeline here. Okay, so at this point, we're going to set the image to be the one that we created back in the last video. So we use the container CentOS 7 image in here. So we can go to deploy, containers, click on that, click on latest, do. There we go, entry point. There we go. All right. So then we'll create a validate and a deploy stage. Why we want to create like two stages instead of just having it deploy is I like to create a validate stage just to make sure, hey, this file is actually valid. Because at the end of the day, you never know if when the moment you like submit an invalid configuration file, you never know how a system might react because it depends on the service. Some will try to like run it and then it will just break the whole service because like half of it will work but the other half won't. Some of them won't even just won't work at all, which is great because then it's like, oh, it's not valid when I'm gonna try it. But you never want to be in that case where you make a configuration change and you have like a weird situation in here that, you know, this doesn't make sense, like there's a record that doesn't make sense, or like something else. This is very simple because this is, you know, a zone file. It's either going to kind of work or not work. There really isn't that much to it. But when you get into more elaborate and more detailed installations and configurations, you got to be a lot more careful. So you always kind of want to validate stuff to say, hey, are my files valid? Will it work? Because you don't want to get into that spot where it doesn't work and then you just take down production, right? So we're going to include validate step. So what we're going to do here is create the validate step, validate script. So to validate, we're going to just use the bind package, which will include name check zone. So with that, most of the time you would do yum install bind, but in this case, I already did this ahead of time, where I actually built and installed the bind package in the container. So you can see I added bind and I also added open SSH clients, which will be part of the valid the deploy stuff for this one. The reason why I did this is so that, especially when this job runs, you don't need to install bind every single time. Because if you have to install bind every single time, you essentially, you know, make it longer, make the job longer every single time. It also provides points of failure. So say, for example, like, you know, the mirror is down or it can't reach the internet, right? Then when it tries to install this package, this job will just ultimately fail. But if it's already built into the container that we created, it doesn't need to reinstall. So essentially it won't need to go back to the internet and it will just work. But really, at the end of the day, you want to try to minimize the amount of installs or anything that is like package related outside of your job itself, because that just adds a lot more time to the job, which doesn't make much sense. And especially if you get jobs that, you know, do more things, jobs never get any faster really at the end of the day. They always take longer because you always add more steps, you add more validation, you add other things that will make it take longer. To make it go faster is more of a conscious decision of, all right, what can I take out of here to make it go faster? So with that, we've already installed bind. So in this case, all we need to do is actually just do name the check zone dragon.local, because dragon.local is the zone in here. We created the dragon.local zone. And then we need to name the file. So dragon.local.zone. So in this case, this should essentially check and validate. And if it fails, if GitLab sees an exit code that's a failure exit code, it won't move to the next stage, which is the important part. And I'll show you what I mean by move to the next stage. So in this case, we'll commit the validate step and can show you that this is going to pass. Unless I have a syntax error or something. So you can see how fast this validate step finished, because all I had to do was just validate the file. It didn't have to do the whole yum install. Otherwise, it would took probably a whole minute for this. So this is minimizing. Like it queued up for 2 seconds, it finished in 2 seconds. Great, right? That's what you want. You want this to be very quick, fast, and simple, because when you do deployments or do any kind of CI/CD, the quicker you can get a response on, hey, this is incorrect or this isn't going to work, the quicker a developer or an engineer can respond back to being like, oh, okay, I know this isn't going to work, let me go fix it. As opposed to, hey, it's going to try to validate, it takes like 20 minutes to validate, they're going to just sit there waiting 20 minutes to wait for it to validate, right? So, all right. Now that we have that, we're going to create the deploy stage. So the deploy stage, there's going to be some prereqs that we will need to make the deploy stage work, but we're just going to create the deploy stage, but not commit until we get all the prereqs done. So in this case, what we'll have is we would usually also install SSH open SSH clients, but we did that in our Docker build, so we won't need this. But the reason why we need this is because essentially you need a way to copy the file from the GitLab runner to the server. There's multiple ways you can accomplish this. The easiest way is to use built-in open SSH packages, which can allow you to use SCP commands, which is just a secure copy, it's similar to like, say you're running like FileZilla on a Windows computer trying to copy a file over to a server or something. This is the exact same thing. It's just between command line to command line. There's no GUI essentially. OpenSSH also is very nice because you can use SSH to log into a server and then run commands on the server too. So we're going to utilize that quite a bit. The next thing is to be able to actually get into a server though, is you either have a key, SSH key to get in, or a password. So in this case, there's no real place to put a password. You could do it, but in this case, you really want to create a like service key, SSH key, and then let it connect together. An SSH key, you can essentially imagine it there being a private key and a public key. Where essentially the private key is like an actual like key to a house, and then the public key is like the door lock. If your private key does not open the key, you essentially got the wrong key, right? So it essentially creates a key pair, which is like a lock and a key. And if they don't match, they won't open. So in this case, we have to create the SSH directory. We don't have to because we can put the key anywhere, but by default, if you put it in the SSH directory, it works. It will automatically try to grab that key. So we'll also cat the GitLab key variable. The GitLab key variable is something that we will create. It is not anything part of GitLab specific itself. It's something that we will create. So I'll show you that later. But we'll put that into the IDRSA file, which is the default file for what keys would be located at by default, which makes it really easy. And then we'll have to chmod, which is change the modifications, the permissions on the file to be 600, which is rewrite for order, nothing else. If the key isn't protected correctly, it will actually give you a huge block of errors saying unprotected key file, two open permissions, and it won't try to use it. Which is a good thing because it's more of a security thing of you don't want someone else to be able to edit your key. Okay, and then the next thing is we'll have to copy the file over from the GitLab server to the server, the DNS server itself. I don't know if I have DNS correctly set up for the runner, so I'm just going to use the IP. I know the IP is 131, so we're going to use the IP. But in most cases, you should be able to also do the DNS if you have it set up correctly. I don't know if I have it set up correctly, so I'm not going to try it. Okay, and then we'll put it in the location where we got it. So this will go into here. The other thing that you actually need to know is, so with SSH, essentially if it's never connected before, it will always give you that weird prompt, which we might have actually gotten earlier, right here. The authenticity of the host cannot be established. It will give you a fingerprint. It's like, do you trust this? So this was created back in the day. So essentially, this is to kind of help alert you of like man-in-the-middle attacks and stuff like that. Essentially, this is saying, do you trust this host? Usually, you say yes to it the first time because you're connecting it to the first time. You're like, oh yeah, this is the host. If you see this after you connect, you might have to be a little bit more worried because if the keys don't match, it means you might not be connected to the same host that you're expecting to connect to. This can happen when, like a company changes their host and use different keys too. Been there, done that. It's a pain, but it happens. So we can't obviously type in yes in this prompt because it's just going to do it. So what we're going to actually do is just actually don't do the check at all. Is this a best practice? Nope. But this is how we're doing it. So we're going to just ignore checking for the host key, which essentially just means, hey, we trust that this is going to be the actual host. In a production environment, you should be a little bit more careful. And then the next thing, we'll do an SSH command, which will essentially log into the server, run a command, and it'll be good. So we have to do the same thing. Strict host key checking, where it doesn't check for the host key. And then we'll log into the server. And then after logging into the server, we will do a reload. So this will reload the zone, essentially, right? Okay, so now we got pretty much the deploy stage all squared away. The next thing is we got to get this GitLab key. So in GitLab, let's go here. You can actually set up CI/CD variables, which is amazing, right? so that you can actually make it so that it's not, hey, something hard-coded into your job where people can read it. Variables are a little bit more better to store like passwords and secret keys, right, for each project. So we're gonna name it the same thing. So GitLab underscore key. This key name needs to match this. So this can be whatever. You can name it keys, key 2, key 3, but this has to be the exact same thing then. Keys, key 2, key 3, you know, the name just needs to match. We're gonna create a file, and then the value. So in this case, we need the private key, right? So let's go back to our server. We'll create a key here. So SSH keygen. The other thing to note about this, so my GitLab runner is running CentOS 8. So if you do an SSH keygen, just by default, so we'll test, we'll just create a test one, right? It creates an open SSH private key. This is something to note because I spent about an hour trying to troubleshoot why this didn't work yesterday, and I went, holy moly. So CentOS 8 is using the latest SSH keygen package, which apparently the new standard is OpenSSH. But the problem is we didn't create a CentOS 8 container. We created a CentOS 7. So it doesn't have the latest package, which it doesn't know how to read an OpenSSH private key. So we actually need to create an we need to create an RSA key. So what we're going to do is actually do the same thing, keygen, but specify it to be a RSA key. So in this case, we're gonna name it GitLab. Won't have a passphrase because if you can't interact in the GitLab again. And then we will cat the key. Now you can see it's RSA private key. So, other thing, you see how I catted my private key? Don't ever do this in a real environment. This is a test key, so as far as I'm concerned, this key will just disappear. I won't even use it after this video, honestly. So doesn't matter for my purposes, but don't ever, if anyone asks you for your private key, don't ever share it. If they think that if they try to convince you, they're trying to do something sketchy to convince you to give them this. Don't ever give this to anyone. But anywho, we'll copy this key, we'll paste it into GitLab. Alright, so now the key's set up. But the other thing is, but we have a public key. So how does the DNS server know what the public key is? What we'll need to do is we'll need to copy the public key. Ooh. Here we go. SSH to our DNS server. And change to SSH directory. Create the authorized keys file. The name of the file is very specific. It's authorized underscore keys. If you name it anything else, it won't know. But by default, it is authorized underscore keys in the .sh folder of the user that you want to access. And then we'll paste it. And then other thing is, so you can see how the permissions is 644. And we'll probably do a permissions video later. But essentially, this is 644. This won't work. You want to do 600. Authorized keys. So you want to get rid of the last two 4/4s essentially, which is read for group, read for other. So now that we have the key set up, you can see if we would go back to our runner and we were to SSH with the GitLab key to the DNS server, it doesn't prompt for a password. So the key works. We should be all set. This is all there. And now we will have it do a deploy. So let's go on the DNS server. Let's change to the von.amd data directory. Cat dragon.logo zone. Yep. Okay. So you can see that we don't have our test entry here, but we will have that. So deploy. Let's do this, guys. All right. So we'll go to project. So you'll see how it still does the validate step. If this validate step fails, it will never do the deploy. It will just be like, it's going to hard fail on validate. So this is good if you have like order of operations where essentially you need something to go first. And if that fails, it doesn't do the next thing. You can also make it so that like the validate step can fail and it'll still go to the next thing even if it fails. Those are like specific cases that will help kind of like, hey, you have like integration tests or like some other tests that you're like, hey, this isn't always 100% working. So it's okay if it fails, but you need to look at it later type situation. Those are like okay reasons to put an okay to fail. But in this case, we don't want it to fail. If it fails to validate, it should fail everything else. So now you can see that it updated the file and it did the RNDC reload. So we should be able to recap the file now. You can see, hey, there is a new entry for test entry now. And also, if you look at the logs, messages, we can see that this actually reloaded the zone. You can see the serial number matches the serial number that we created in here, ends in 54. And now you can edit this file, and every single time you commit, it will deploy out the file to the server and reload the zone. So now we don't have to ever log in to get the DNS server itself. We can actually just edit it in here, which is cool because this is one of the easy ways to source control file. Because like if you edit on a server, there is no version control, right? But you can see in GitLab, which is nice, where if you go to code and commits, you can see each version of the file. So you can see invalidate how I only had just the validate stuff. I didn't even have the deploy stuff. So this is a great way to be like, oh, okay, so what was my version right before this version? Say you forgot, you create a backup file or something. The GitLab is a good way to version control your configuration files without needing to worry about backing up files. But you should always back up files. If you ever work in a production system, always back up files. But in this case, this is a great way to edit, update, and deploy. So that concludes this video. Hopefully you enjoyed, learned something new, and maybe now you'll start deploying configuration files via GitLab. There's also other tools to use, so we'll probably explore those in other videos, but this is one way to do it. So if you liked the video, please leave a like, comment, or subscribe, and we'll see you guys in the next video. Bye.